Let's talk about Sal Pais and the Superforce. Interesting concept, isn't it? But it's not new. This is something he came out with a while back, and there's some people that I think have invented the machine he's looking for even before he came out with the process. But let's get into it a little bit and find out what it is that he's pulling things from. You know, I see a lot of interviews out there, and they always ask him the questions, but I don't think they're understanding what he's trying to tell you. And it might be because you're a physicist looking at an engineer's work, and there's a little bit of crossover that needs to happen there. So let's get into it a little bit. What is the Superforce? Well, it's the ability to stack multiple layers of electricity on top of each other. So in order to create that, how would you go about that? See, let's just look at it in a very simple understanding and way. This is one layer, right there. So what do? We have energy going in here to each one of these layers. If you were to put a pickup coil, just like this, with your wires hanging out, and I put it right here, I should get a massive amount of energy, right? Just massive. Why? Because you're picking up this layer of energy, plus this layer of energy, plus this layer of energy. You say, well, that doesn't look too impressive. You only got a couple lines on there. Well, yeah, but when you make it 1,500 times, it multiplies it quite a bit. So that's the first thing. Now, the second thing is each layer is held in. If I told you it was this, now I fill it with energy. In this right here, we're going to do it on the Planck scale. But it also works on the outside scaling of our universe. So, this right here is now replacing the line. I now have multiple energy fields in here. Now, we'll take out the rod. We don't need it, and I'll just do it like that. What happens to the last field? You see, the last field on this is designed to go like this. And why? This is the heavy side component he talks about. People generally say static electricity, and static electricity is right. But it's the capacitor takes in, if we just do 2 posts on it, it goes in and out, right? You would normally associate this with the capacitor. This is standard understanding. What if I told you it was a different understanding that he's looking at? I'm going to take it in and discharge this capacitor with the static electricity. See, I don't need the wires. Not at all. I'm looking for leakage, and I'm looking to be able to absorb it into the capacitor. You ever run across that phenomenon when you have this stuff in your shop and you have a capacitor that for some reason just comes back to life that you didn't short circuit in the drawer? You maybe thought you discharged all of it and then it comes back. Maybe you did some experiments with static electricity and found some capacitors laying close to the same place you're working in, yet they filled up. Maybe they might be halfway bad, I don't know. The phenomena happens. This is what you're looking for. So as each layer of this builds, you're also building capacitance in it. The energy comes in, Energy comes out. This is your heavy side component. So, right there, now we have this. The whole thing with this is it has to pull the energy in all the way. So, there's a rotation. It's as simple as this. Everything vortexes. And the energy comes around. That looks pretty familiar, doesn't it? I know we talk about this a lot on this channel, and there's a good reason for it, because this right here gives you this. In this, okay, that is a room temperature superconductor right there. Why? You see, we don't need liquid nitrogen to cool this thing down like you would a magnet. It's the energy itself that cools it. You cannot force cooling in this, just like you can't put liquid nitrogen down the center of it. The room itself, or the atmosphere that you're standing in, has to be able to provide this. Sal said it so himself. Therefore, everything that comes in here makes this thing colder. Right there. It's got to make it colder. Now, why do we say it's colder? It's the actual environment doing the work. It's showing you that the energy is going in there. It is not the fact that it's cold is what you need to look at. It's the rotational flow of the energy itself that you need to look at. In order for this to work properly, this must happen. You see, this is the effect. It's not the cause. When we pour liquid nitrogen in, that's the cause, and you get an effect. This is not the cause. This is the effect. Now, every time you work out in this, you get the same thing Sal tells you as time dilation. Every time these fields right here, you get a, let me draw them a little better. These fields are crossing fields. Crossing fields is required in order to create time dilation. This right here, this simple field, is this same field right in here. This is on the Planck scale. This is more on the universe scale. You could just simplify it and say it on the Earth scale. Or you could even go smaller. The locality of your room scale. Planck force, room scale. Pretty easy, right? It is the exact same force. In order to build this, you must take a radiant field, whether it's positive or negative. You must then create a static field. The radiant field holds in the static field or pushes the static field out, depending on how you have it built. Now, what happens in his patent? He's telling you in a vacuumed environment, not in the environment in your room, but in a vacuum environment, that you're going to build in this layer right here. Plasma. You are building plasma in here. These two layers are affecting each other like this. The layer in the center starts to create plasma. Now, I've seen this before. I've built this before. It will absolutely create plasma. In order to make that plasma easier, again, it depends on your environment. If you vacuum it, you can get to the plasma easier. What's the problem? If you start vacuuming things, you're looking to run things in space. If you're looking to not vacuum things, you're looking to run things on the Earth. Locality matters. You have to understand the environment that you're trying to work in. This force does not need a vacuum to create. It will create without the vacuum. Please let me say that again. It will create without the vacuum. Does the vacuum make it easier? Yes, it does. It's easier to see for people. Is it necessary? No. This right here is the understanding of this. Now, we have this simple form. How do you get there? Okay, we understand these components. This was probably the easy part of this. For those of you out there, just so we know this, okay? You haven't done the test on the gravity flyer and you're saying it's just a piece of junk, you should please go look in the mirror and really find out if you want the answer. Because the answer to the field itself was in it and you didn't see it. I did because I did the test. You have to crank everything up. You see, high voltage doesn't lie to you. High static amounts don't lie to you. They tell you exactly where they want to go. The fact that you haven't done it says you don't want the answer. So, do the test. You're going to find out radiant field holds in the static field. Flip it the other direction. The radiant field will push the static. What does that mean? It means that you can confine the static. You can confine it down to a Planck scale. You can also build it out to create a barrier on the outside. Do the test. So, how do we get to this? How do we get to the supercapacitor, right? I want to start with geometry. Simple shape, hexagon, we're looking to create this, right? I'm not just going to create it once. See, I got a layer there. I got a layer here. I have a layer here. I simply put 3 layers on it. And I still haven't made the design I'm looking to make when I wind this coil. But I've already put 3 layers on it. You see, getting to 1,500 layers is not a problem. Cancellation is your problem. You have to figure out how to not cancel it. But is this coil one coil? No, it's not. You see, there's 2 coils in here. Sometimes you can add a third depending on the effect that you want. Sorry. Each one of these designs, when you do this, like Gerald will tell you, you have to do it 180 degrees out of phase. What does that basically mean? Well, maybe I shouldn't tell you that one, but you'll figure it out as we go. You want to create this. This is going to create your impingement. Now, each one of these corresponds to each one of these lines. Every time I drew this, and we knew that each one of these lines, like we said here, is now filled with static, and we're working on the Planck scale. That right there, that's how you design and build this thing. So let's look at some other components of it. I don't want to get too much into this. I'll be very honest with you right here, it's not my work. I built it, but this is not my work. Not on that coil. That's all Gerald, and I give him credit every day of the week for it. It's his, belongs to him, has for a long time. Have to refer to him on that. Other than that, let's get on to some other things, okay? I got a little cheat sheet here I'm looking at. Remind me so I don't lose anything. All right, we already talked about the superconductivity. So, what does superconductivity tell you? More energy and it gets colder. I guess that's an oversimplification of the definition. More energy gets colder. Where you're confining energy and you're confining it in layers, right? You're going to get more energy. What does that mean about your circuits? Well, you don't want heat in them. We know already from Steinmetz, heat is hysteresis, which is loss. We don't want loss. Can we design a system that creates no loss? Well, yeah, we can. It's not hard. We run things in the negative. You go, well, you can't run things in the negative. A PNP transistor runs everything in the negative. It's not a new concept here. The difference is for every PNP you put out there, you have to put resistance in it, or you can't trip the actual transistor. There's a way around this. You see, we just have to take an NPN transistor and make it do the job of a PNP transistor. So you pull the negative through your system. There's also another way. You can use spark gaps. Tesla used spark gaps all the time. Dissipation of heat is what you need. If you have heat in this system when you create it, in order for the coils to fire off, you've already not made the superconductor at all. You've failed. You've absolutely failed. If you ran PNP in the positive format, you failed. You have to run it in the negative. So take everything you think you know about positive and how the circuits work, just put it in your head of a PNP, now remove the resistors. I've never seen a free energy experiment that has resistors. There might be a good reason why. I've never seen anybody who sits there and deals with circuits all the time and runs everything in the positive create free energy. Maybe there's a reason why. Every engineer who looks at this in the negative has one thing that they have, a character distinction that they have that most people don't. They have dyslexia. They see things in reverse. You have to understand that. If you understand the mind of the inventor, you understand what they invented. A lot of them see things backwards, and engineers do it all the time because things don't always work in the way that everybody thinks they're going to. They have to create and make things to go backwards in order to get it right. It's a simple understanding, very hard to be able to put in your head and put it into a format that works, that gets you to do it, unless you can figure out why. Kind of an interesting concept, right? 0 point and the superconductor, all of it's the same thing. All of it. All of it has to be created at the same time. Time dilation goes with it. It has to be created at the same time. Every single one of these components are in it. They don't change. They can't be separated. Can you create over unity without this? Yes. That's not a problem. But if you want to create 0 point energy, you want a room temperature superconductor, they have to go together. Let's go into another force here. He does not mention this, but we look at the Byfield-Brown effect. Okay? We got electric, we got magnetic, gravitational. Let me simplify this for you. The gravitational is your radiant energy. It is a factor that has to be in there. This right here is what you get here with the big G, gravity. Okay? They're usually talking about static here. Plasma here. Now, why do I say it in that way? I know that it's kind of controversial to look at it that way, right? But I just told you how the fields are built. I took a radiant field, I took a static field, I get a plasma field in the center. Well, that's your anti-gravity effect. Right there, you have just canceled out gravity and created your own. It's not hard to understand. Hardest part about to understand all this is the actual temperature differential you're going to get. You see, when you do this, we talked about it getting cold in the center. Gets colder here. That stays room temperature. Now that means that when you're flying through the sky, whatever that temperature is you get, but that's going to be cooler. And it doesn't have to be a lot. Guys, we're talking room temperature and below, okay? Anywhere you can get it under that, you'll start to get the effect. When you get 3 degrees under the room temperature, you will start to see the energy pick up. The energy starts to amplify. Matter of fact, I've seen it double instantly in seconds. Okay? This energy likes to pick up and run and get things going. You are now going to start putting off gravitation waves. You can't avoid it. You can't avoid it. That's why I tell you the G goes in the center. You see, the radiant energy, the plasma, the static, all of it are in there. Depends how you build it. Sal's not wrong on this. He's right. He's putting things in there you can't see. So I found this. That's in there, by the way. He didn't tell you it's in there. He infers it's in there. You see, he likes to infer things that are in there and not tell you that they're in there. He does it a lot, and he makes people confused as soon as he says it. I've seen every single person that's interviewed him not understand it. They'll pull out the physics of it, but they won't understand the mechanical of it. He's an engineer, not a physicist. Please understand it from an engineering perspective. He tells you in the plasma. You start to see geometrical forms in the plasma. Guys, there's only one way to get that. You have to create the geometrical form itself. Then, it'll show up in your plasma. Every single one rotates. One coil counter to the other one. 180 degrees out of phase. One goes up, one goes down. Both have to be created. Not one coil, it's 2 coils in one coil. This will be in your plasma. When you get to the state of seeing it, you knew that this already was the creation that you had to start with. He tells you in the plasma, geometrical form in the plasma. Just understand that. It's no different than putting your speaker on a little thing of water. Okay? Get you a pie tin, put a speaker under it, put some water in it. You're going to see right there the energy. Put it in sand. It'll be a different form, but it's still the energy. You see, geometrical shape is how this world works. He knew it. He told you it. You didn't listen to him. And everybody that I've ever seen interview him and passed it by. You did not recognize he did this. And he's telling you it's in there. You're failing to hear it. Now, I do a lot of things when I break this stuff down, guys. I need you to understand this. I literally take what is said out there in the interview. I cut out all of the questions. I cut out all of the hee-haw, the laughing, the giggling, the playing, the super excitedness. I get down to the base words. What is that man trying to say? What distinctly is he trying to say in that little short time? In each single segment. You can learn a lot from an interview that way. All that other stuff is distraction and noise. I don't need any of it. Matter of fact, I don't want it. I want what he's trying to corely talk about. Right there, just that little bit. It gives you more answers than that entire interview. It may be 30 minutes of a 2.5-hour interview, but it is the most important part of everything. Cut out the garbage. Get your mind out of the way. Stop trying to overthink of what he's doing. Take what he's doing and put it into format. That's what you have to do. Get rid of the garbage. So, we talked about the fields, we talked about the geometry shape, heavy side component, all of it's in there. We talk about the capacitor, speed of rotation, in geometrical form, in a winding. I'm going to take this right here, and I don't want to say this. I just want to do another one. Sorry if I get this wrong, I'm going to do it real fast. I need the speed in which this rotates. You see, putting a motor on it, putting a disc on it, putting energy on it, too slow. In order to get that plasma state the way he wants it, this has to be fast. So every one of these, now multiply it. $1,500 layers. This is a minimum, by the way. This is a minimum. By 1,500 layers. Rotational speed. Now, energy's fast. Much faster than a rotating disc, right? How fast can you go around that geometry? How fast can you get up in that coil? That's the speed you need. Now, depending on how much resistance you have based on the material you use, copper is going to have some resistance. Guess what? Put this thing in silver. Less resistance. Wow. Put it in gold. Less resistance. The difference in material at this level changes it. So, do we need metamaterials? No. We do not need metamaterials to build this. To amplify it when we're done, maybe, you could start changing things out, but not at the base level. You see, we're not putting the carriage before the horse here. We have to put it in its proper place. Build it first. Then, take things out one by one and see what amplifies it or if it makes it worse. That's how you do this kind of work. You don't just go for the gusto out the gate. I'm not just going to go buy, 10,000, 20,000 worth of gold so I can wind a coil. No, thank you. I'm going to do it out of copper first, see my reaction, then I can go ahead and move to other materials. That's the way it should be. All right, we talked about the Planck scale. Now, I know people don't understand this when he says it. It's the same as the Planck scale as the energy scale. Why? Because it's the same energy. He's building the same field in both. I mean, you got to start to understand that. He's building the same field in both. I told you about the temperature differential. That also means that I'm building a negative radiant energy field in the center of this. I'm building a positive radiant energy field out here. What does that mean? The heat and the cold. Heat and the cold, heat and the cold. Always the heat and the cold. Always working for the heat and the cold. Let me redraw this for you so you get it right. Always. Always the heat and the cold. Just like that. I had a chance just recently to talk to an individual named Nick about a corona motor. And it's really kind of a bad name for it. It's more of a corona generator. It's taking in the energy, and it kind of tells you something about what we're actually doing here on Earth and why that would make more sense here. If you think about it in a corona motor, or in this case we'll just start calling it a corona generator, you're pulling in the environment into this generator. It's generating electricity to run the motor. Okay? That's the interesting part. Were we doing it the whole time with every generator? Energy cannot be created or destroyed. So, were we doing it the whole entire time? We not realize that that's the process taking place. We're pulling in the energy from our environment in these things. And it's giving us the energy back so that we can turn it into AC, DC, whatever we choose. It's the understanding of that corona generator / corona motor that gives you that understanding. You see, it works just on the atmosphere pulling in energy. But then again, could put a radio in the ground and create energy. The energy is already there. You can't create it or destroy it. You can only use it. You see, that's the fallacy of science here. When you get to engineering, you're looking at volts and amps and running a motor, right? Or it's pulling in the volts and the amps. Well, where the heck is it pulling it from? They say, well, the magnetic field, and it goes against this, and it creates some tension in there, and it creates it. Okay. What if you defeated Lenz's law and you're able to do it and get that process where that isn't in there? It still gives you the energy. So you have to ask yourself the question, did we get it wrong in where the energy comes from? You see, to me, it all comes in from the room, the environment, what you're standing in. It's always come from there. It can't be created or destroyed. We don't understand it as energy. It's one of the fallacies in our mind. That's the problem. If you saw the room as energy, the sea of energy is always around us, okay? Nikola Tesla. Start to learn it. All we need to know is how to harness that energy. That's it. If you could think of the chronomotor, chrono generator, as how it works, that you're pulling things into it at all times. The environment's always being pulled into it to create the energy. If you can start to think that way, then this process is so much easier. We have all the energy to pull in there. It's all around us. The whole fallacy of a closed circuit unit, that's just your primary mover. That's just how you turn it on. That is not the energy you're looking for. That's just not it. Who cares? I could care less if it loops. I care about the energy in the room. How do I affect that? That's the whole thing here. That's what you have to start to get your mind wrapped around when you deal with something like Sao Pais. You have to pull in the energy from your environment. You cannot do it based on your prime mover. They're not wrong when they say that you cannot do this any more than looping your system. Looping your system is possible, and it's actually easier than you think it is. It's building the right part is the hard part. The rest of it's fairly easy to understand, but the understanding of how that chronomotor / generator works gives you a better understanding of where the energy is coming from. You pull it in from your environment. That makes this process a whole lot easier. Geometrical structure in order to pull in the environment. Remember each layer. 1, right there, 2, 3, 4. Pulls in the energy from your environment. If you can get it to not cancel each other out, you've got it. That's it. You know, this thing 12 years ago was built. And Gerald's been looking for somebody to understand it. That's a fact. So, guys, I hope you understand this. I hope you understand where we're going with this. This is not that hard. I don't know that how much I can get into this. I had some people ask me if I could build it. You know, Gerald's my friend, and I'm not going to cross that. And no matter what happens or, you know, what other people think, I'm not crossing that line. When he comes out with it, he'll tell you. I'm not doing anything around that subject for that reason. And, you know, he shared things with me that are private, and that's the way they're going to stay. And no, I don't have all the answers to that. I have what I think are, but God, who knows? Everybody's got answers, right? I do know how this tech works, though. Very much so. And let me just give you a little tiny bit on the end here. You guys want to take things and transform them. And you want to understand the nature of everything. When you get into this kind of tech, you're going to start transforming things in the center of this. You see, I don't have a bunch of wires in this. This is open. This right here in the center, this part, completely open. it's going to transform the energy from one kind to another. It's going to pull it apart. The harmonics in this thing are incredible. You talk about the thunderstorm generator and the harmonics. What do you think this thing is? I mean, all of it's in here. Harmonics, octaves, everything you want to say. You know, A minus, A whatever, A sharp, all of it in here at each level of it. The inside on every one of these has a different frequency point. If I said this is A at 55, this is A at 110, this is A at 165, that's the way it works. You pulled the Russell scale right in the middle of it. Okay? Sorry, that's the way this tech works. You get all of it. You get all of it. There's no getting around it. Just depends on how you wire it. You wire it for certain things, you get certain effects. You wire it for certain things, you get different effects. That's how this works. Anyway, guys, that's it for today. Hopefully you understand this. This work is not crazy pseudoscience. It's actually easy to understand if you understand geometry and how it works. There's a couple more things that I could say in here, and I just won't because I'm going to value my friendship over giving everybody the understanding in that way. So I hope you guys understand that. With that said, have a great day. Before we get out of here, I just want to let you guys know that I offer memberships on my channel now. It's a really cool thing. I do behind the scenes stuff. I give you more information. I also put things out early on it. All of my Fringe Think Tank Star Trek episodes will be on there. I just put out another one, a number 7 episode. Also, you're going to get emojis on there that you can use in the live chats. They're pretty cool. And as we grow our membership, I'll be able to put more emojis out there. Just a fun way to liven up the chat a little bit. Don't forget to like, share, subscribe, and comment. And have yourself a great day. Thank you very much.